Everybody, my name is Thiago Aldrovandi. I'm a student of the last semester of the School of Medicine, and today I'm going to present my work, whose advisor was Professor Fábio Teodoro Souza. To get started, we know that air pollution has been associated to a variety of respiratory and cardiovascular disease. We decided to make predictive models based on data mining because they can be simple, low cost, and accurate tools. In my survey, I found just a few results that were done at the national level and mainly at the local level that could invade public politics. We chose asthma and pneumonia because they have a great clinical and epidemiological relevance. To talk a little more of each disease, the asthma is characterized by an airway hyper-responsiveness and is triggered by allergens, irritant exposure, and sometimes by exercise. In Curitiba, in the last 5 years, there was 2,039 hospitalizations. On the other hand, pneumonia is characterized by infection of the lower air tract. It can also evaluate to sepsis and respiratory insufficiency, and in Curitiba, in the last 5 years, almost 13,000 hospitalizations. The objective here is to see the relations between air pollution and the disease, create protective rules in order to embase the creation of public health policies. The method we are using is based on data mining that can be divided into 3 steps: data collection, preparation, and modeling. And after, you can create the classification rules that has this forecasting perspective. So for the data collection, DataSUS provides a number of monthly hospitalizations by each illness. The meteorological data was given by SEMIC PUCPR, and the air pollutants such as smoke and total suspended particles are measured by the Instituto Ambiental do Paraná. After the collection, data preparation is the step where we correct inconsistencies, missing data, and fake zeros, and prepare the data for data mining software. In this case, we use the CVA. To do so, we divide each variable into tertiles and turn the quantitative into categoric variables. And to make this temporal approach, is needed to create an output variables of time. The data modeling consists of multivariate analysis and the creation of quantitative models. For the multivariate analysis, we use 4 techniques: 2 statistical and 2 clustering methods. After, we create the classification rules of if-then type. Here's an example. When the condition in the first box is satisfied, then we're going to have the result in the right box. In this case, I took 3 different levels of total suspended particles and the occurrence of asthma hospitalization in 12 months. So when you have the concentration of TSP is lower than 20 and the wind and the mean speed of wind is over 2.5 meters per second, we're going to have less than 25 hospitalizations for asthma in the next 12 months. The same logic is applied to the other rules. Here's another example using carbon monoxide concentration measured at Boqueirão Station and the hospitalization for pneumonia. This number here shows that in 100% of the time that this condition took place, we had less than 170 hospitalizations. This method showed an accuracy over than 96% in all scenarios. It's important talking about the limitations as well. Time data is not available, so you need to use means, and so there's some deviation that you need to take into account. Some updates are necessary, mainly to the Instituto Ambiental do Paraná, that most recent data is from 2016. Also, the DataSUS doesn't differ as community-acquired pneumonia from nosocomial, for example. There's also a lot of missing data in the reports, and it takes a long time, even months, to receive an answer from the public organs. In conclusion, this method is low cost, the software is simple, and do not require a supercomputer to run. The variables are already measured, so there's no need of creating a whole new stuff to do it. And that's it. Thanks for the attention.